Okay, so the first thing that we have new coming in soon is um, pretty big update to LocalNet. So if you're a developer on ZetaChain, you probably know what LocalNet is. It's a very handy tool for developers to run a blockchain environment locally where you can deploy your contract and interact with it, and it features several EVM chains running on the same local blockchain that you can interact with. So if you're not familiar, go to zetachain.com, search localnet. Um, it's very easy to use. And in the next release, we are shipping on abort functionality, which is going to be very useful um, for most universal apps. And I'm going to demo it right now. So if you want to follow, just git clone the example repo, so github.com zetachain example contracts. And there is a branch called on abort, which demos this specific functionality. So this functionality is not yet live on testnet. It's only available on localnet, but you can already start using it to prepare for when it's released on testnet. So the example we're interested in is called call. If you go into the call directory and run yarn to install dependencies, you can see in the package JSON that localnet is version 5 RC1. So it's pre-release version, but it's going to be released as stable soon. So once you have dependencies installed, you can open the localnet shell file, which basically just starts localnet and runs, deploys the contracts and runs these uh, contracts, interacts with them. So one example I wanted to share is, so let's take a look at the example first, right? So there are two contracts, one called connected deployed on, well, a connected chain, for example, Ethereum or Polygon, and one is universal deployed on Zeta chain. It has a bunch of functions basically for demoing how to make calls, how to withdraw tokens, and so on. And we're uh, interested in this specific use case where you're making a call from a connected chain to Zeta chain. So if you go into the connected chain, there's this call function which calls universal contract on Zeta chain, and this on call gets executed. And not this one, right? And on call is very simple. It just emits an event. So it's pretty much hello world. So that's the way it looks right now. And let's run localnet. So scripts, localnet, start. So this command is just going to run this script, deploy the contracts, and run this call. Let's give it a second to deploy the contracts. Okay, so let's see what happened. So on Ethereum, gateway was called, deposited and called, event emitted, and the universal contract, so this one got executed, on call executed, right? And we got an event from on call. So that's expected, right? You make a call and you get an event. Now let's say this call reverts for some reason. So let's just introduce a revert and run the script again. So what this should do is it should make a call from a connected chain to universal contract, and on call reverts. which means that the connected chains on revert should be executed. And we see exactly that, right? So on call got executed, but it encountered an error, right? It reverted, and now the same contract on Ethereum got executed on revert, right? And we see a message from inside on revert here. So a call is going from Ethereum to Zeta chains on call and then back to Ethereum's on revert, and we see this event being emitted. Okay, that's useful because if you're making a call and it errors for some reason, you should be able to undo the action you made on a connected chain. Maybe you're transferring an NFT, so you might want to lock it and then unlock it if the transfer failed, for example, or do something else. So that's good. But to make this revert, a universal contract actually had to, not the contract itself, but Zeta chain on behalf of the contract swapped the incoming tokens to cover this cross-chain transaction that triggered on revert. So we had one transaction coming from Ethereum to Zeta chain and one transaction coming from Zeta chain to Ethereum triggering on revert. So universal contract paid that. And this fee was deducted from the amount, and the amount is big enough that this worked out very well, right? But what if the amount was small, not enough to cover the on revert call back to Ethereum? Let's see what happens then. So compiling contracts, deploying them, and making the call. Okay, so that's rather interesting. We made the call, on call failed as expected, and then we initiated. So previously, the contract would have been able to initiate a revert back to Ethereum, but the deposited amount is actually now less than the gas fee required to make this revert call. So in the current version of Zeta Chain on testnet and mainnet, that would result in an aborted transaction that just like the funds remained in the contract and nothing got done, right? Because the execution reverted and there was not enough tokens to execute the cleanup function on revert on Ethereum. So that's not great because what if a user submitted an amount that is insufficient, right? You still want to handle this scenario. So with on abort, if this situation occurs, an on abort function is executed on Zeta chain. So if we go back to the universal contract, we see that there is a new function called on abort. So if on call is reverted and there's not enough tokens to make a call back to Ethereum, then on abort gets executed and it gets the same information. So you have abort context, which contains the message, it receives the tokens. Uh, what this allows you as a developer to do is to basically execute a function in case everything else fails, right? So the call you intended to make reverted, the tokens were not enough, right? The amount was less than required to make a revert. So at least you can execute some code inside on a board. So this is super useful because one example is universal NFTs. So universal NFT is a contract you can deploy on Zeta chain on connected chains to mint NFTs that can be transferred between chains. Very handy contract. And on a board is going to be used in this contract to send NFT. So in a scenario where you're sending an NFT, let's say from Ethereum to Base, and the transfer failed, and a user just happened to supply an insufficient amount of tokens, previously an NFT would just kind of basically be lost. So you would have to kind of work around that and implement an admin function to kind of unlock it basically or do something about it. But now with on a board, this NFT can just be transferred to the sender on Zeta chain, not back on the source chain, which would be a perfect scenario, but you don't have the tokens for that. At least we can send the NFT to the sender on Zeta chain, and then they can manually send this NFT back to the source chain, for example, or try again and send it from Zeta chain to the destination chain. So the NFT is not lost, and that's thanks to the on a board functionality. This version of Universal NFT is actually available in a PR, so you can already check it out. So this is incredibly useful, but this is not the only scenario where on a board is executed. Another scenario is when you're making a call from Zeta chain to a connected chain. For example, here, right, we're making a call to a receiver contract on a connected chain and it fails. What happens then is on revert gets executed on Zeta chain, right? And it doesn't depend on the tokens you submitted, doesn't depend on pretty much anything, right? Execution on Zeta chain is free when you're making a call from a connected chain. This covers reverts as well. But the problem is this on revert function may also revert. I mean, it shouldn't happen, but it could happen. So if that happens, on a board gets executed as well. And inside a board context, you actually have a field, a board context outgoing, which is either true or false. So if the call is from a connected chain to on call, it fails. On a board, it's executed, then outgoing is false because it's incoming, right? But when the on revert fails from an outgoing call, outgoing is true. So very versatile, and this doesn't really unlock new features, but it makes it easier to write a more robust universal apps that basically can handle any kind of scenario, even when everything else fails. So this is available in LocalNet 5.0, yeah, 5.0 RC1. Going to release stable version soon after some small fixes. So yeah, you can already install it. Check out this branch and the examples contract, the examples repo to see how it works. And it's coming to testnets probably in the next release. I'm going to post docs about on a board and how it works and share it on Discord. Um, hey, any questions? No questions so far. Moving on to the next topic I wanted to cover. It's universal NFTs and universal tokens. So if you're not familiar, this is a very handy contract that I mentioned already, but you can now install it from NPM. You can add this, you can install this contract in an existing project, or you can take an OpenZeppelin template, for example, and you can see how to add this functionality to any NFT. So it makes it very easy to take an existing NFT that you have the rights to upgrade and upgrade it to Universal Contract. It has to be OpenZeppelin upgradable for that, but other than that, not that many requirements. So it's a pretty straightforward process to upgrade an existing template. To make starting with kind of building universal apps easier, actually added a small utility, which hopefully is going to make it easier to get started. So it's called Create Universal Contract. If you use Yarn, you can, let me see, I think I have an NFT already project. So Yarn Create, if you're not familiar, Yarn Create is just a tool that calls an npm package called create dash something. In our case, that's universal contract. And this basically goes to the example contracts repo, fetches all the available contracts, and you can choose which one you want to use. For example, I want an NFT, and it just clones the appropriate contract so you can kind of start building very easily. So yeah, if you can maybe you want to swap example, you can easily get a swap example and kind of start building from there. So yeah, just a small utility that hopefully is going to make uh, developers' life easier when you want to experiment with stuff. I know I'm going to use it um, for example contracts for when I need um, basically a template where there is a universal app and the connected contract with no logic inside. So just a template that has these contracts and set universal, set connected functionality, like all of this stuff that you don't want to retype or copy paste. You can just like clone it. It's not here yet, but I'm going to add a simple example for that so you can clone it and start building. Okay. Um, Moving on, we have one more update I wanted to share is Third Web. So Third Web is it's a great platform that basically provides a way for developers to kind of start building, deploy a contract in browser without switching to your terminal. You can just deploy a contract from your browser. So if you go to thirdweb.com/docs.zetachain.com, this is our username. It's actually an ENS name, which we're using. Let's try it again. So this is the official Zeta Chain's uh, account on Third Web, and it has all the contracts. So, for example, you can deploy a universal NFT, just click deploy, and fill out the name, the symbol, select the chain, where in case Zeta Chain, in case of universal NFT on Zeta Chain, it's going to be Zeta Chain. But for universal NFT, you can also deploy that. So you have to have at least this contract, but you ideally have both, so you can send tokens between chains. And um, yeah, once you deploy these contracts, you can send NFTs between these two blockchains or however many. So this is very handy. You can also experiment with the swap example as well as some other. So we have a cross-chain message. It's not really ready for production. It's just an experiment, but it's basically message passing without deploying anything on Zeta Chain. So this is probably gonna come in the next couple of months, maybe. But in the meantime, yeah, I encourage you to check out Universal NFT and Token, which is contract for sending your C20s between chains. Check it out. It's very easy to use on Third Web. You can do it from the browser without installing anything on your machine, and you're going to have a contract. And it's also upgradable, so you can deploy it on Third Web and then continue developing it locally and just upgrade the contract once you have a new version ready. Right. Those were all the updates I wanted to share. Let me check if I actually mentioned anything in. Um, yeah, so one last thing I wanted to mention is that the contracts, the Universal NFT and Universal Token contracts, are currently being audited. So once that's complete, we'll publish the report as well as start working on fixes. Hopefully, there's not going to be that many fixes. That's I think it's going pretty well. So once the contracts are audited, it will be much easier for developers to use these contracts in production. And we are already working on the next version of Universal NFT and tokens, which take advantage of these new features like on a board. So it will be possible to still use the V1 because as long as you supply enough tokens, there shouldn't be any reason for the universal contract to call on a board, but the V2 is going to be a bit more robust in handling these edge cases. So if you have any questions, no questions. Um, well, thanks so much for tuning in. This was a very quick update on what's going on with developer tools on ZetaChain, and see you in the next one.